So a salamander swims using what's called umbiliform swimming. So it's a traveling wave of body ondulation going from head to tail, exactly like eels or lampreys. And then if you place the salamander on the ground, it will switch to a quite different gait. And this is called a walking trot gait. So you have periodic activations of the limb, you have a nice body ondulation, but it's a quite different gait in the sense it's now standing wave ondulation as opposed to a traveling wave ondulation. It's a bit technical, but it's quite different. And one thing which is amazing is, it's not very nice for the animal, but you can denervate it, like remove upper parts of the brain, electrically stimulate the descending pathways, and what happens is, at low level of stimulation you have a walking-like gait. You stimulate a bit more, it goes faster. And at some point there's a threshold, and if you stimulate more, it goes into swimming mode. And this is amazing. It really shows that the spinal cord can organize completely different gaits by just changing the global drive that you apply from upper parts of the brain. And this is something where mathematical models and robots become useful to try to guess how this works. So we make mathematical models of these circuits, starting from a swimming circuit, like the primitive lamprey-like circuit, and then adding new layers to represent the neural oscillators which control the limbs. We know where they are, and we couple them together. To finally, we made a model, basically we could replicate this transition from swimming to walking with very simple inputs. And let me show you the robot. So the robot here will do exactly that. And so what's nice here is from a remote control, we just send two signals, which are essentially these red arrows here. And these represent what the upper part of the brain sends to the spinal cord. And then it's really the spinal cord circuits which organizes all the signals to the muscles, for instance for swimming, for walking. And you basically just have to play with these two signals to go faster or slower. If you stimulate more, you go faster. If you stimulate more one side, you turn towards that side. If you stimulate below threshold, you walk, and above threshold, you swim. So I find it very fascinating. It really shows that the spinal cord has a very sophisticated circuit, which just modulates very simple descending signals for steering and control of speed.